Hello IB. I thought we'd run through the last part of 7C. Some of you missed class, and so we're just doing a recording of some of the harder binomial questions that you could come across. So what we want to look at in this example is how to find a constant term. If you remember, say back with y equals mx plus b, you've got a term involving x, the mx, plus b. This is a constant term. There's no x's involved. It's just a number. So when we expand this binomial, because we've got x's in the numerator and the denominator, we're going to find that at some point they will match each other and cancel, and we get a number that's a constant term. So there's no x's involved with it. I'm just going to clear this out of our road. So we want to find a term where the x's cancel. In other words, the power on x becomes x equal to 0. So we want a term that is term where x has a power of 0, and that's going to come from, remember when we do our any general term, we're going to have our 3 brackets. So we're going to have some sort of coefficient, and that will have n equal to 12, because it's a power of 12. Not sure what the r is, let's leave that at the moment. What's in here? We have 2x squared, and in here is minus 3 over x. This is going to be some r value, because we don't know what power we're after, so that's the r matching here, and this is going to be 12 minus r. Now we're really only interested in what's happening with the x's. So at this point, I'm going to drop out or leave out all the other coefficients. So leave out the coefficients. All right, and that will make our problem a bit easier to work with. So we want a power of 0 on our x. The 12C3, that's going to be a coefficient, a number, so we're going to leave that out. We're also going to leave out the 2 in this term here, because that's just a number. It won't affect the power of x. So we're going to have x squared to the power of 12 minus r. And the other term, we're leaving out the minus 3, because that's just a number. We're going to have x to the minus 1 to the power of r. Let's use our indices rules to expand this. So that's the same as x to the 24 minus 2r, expanding that, times x to the minus r. Now we know if we've got the same base, so we're multiplying them, then we can add exponents. So we've got x to the 24 minus 2r minus r makes minus 3r. So we'll write that out. And I'm going to do this in one step. We can see that if this is the exponent on this side, that's going to match this exponent. So in other words, we can say that 0 equals 24 minus 3r. More space, 3r equals 24. So r equals 8. So now we know that r is 8. That will make the constant term. But we actually have to find the constant term. So let's now substitute it all back in. Leave it there so I can still see it. If r is 8, then what term is it? It'll be the 9th term is our constant term. So that will equal 12C8 times 2x squared to the 12 minus 8 is 4, minus 3 to the x to the power of 8. And down here a bit. So then we need to use your calculators. Oops, sorry. We'll get rid of that little mark. That goes, we'll get rid of that while we're at it. All right, so we'll use the calculators for 12C8 in a moment. We then want times 2 to the 4th times x to the 8th. So don't forget the power of 4 acts on the 2 times, don't get your x's and times mixed up, minus 3 to the 8th. That goes in brackets because it'll need the negative dealt with, x to the 8th. And that's where we can now see that the 8's cancel because we've got one odd in the numerator, one odd in the denominator. So then we can then put all those into your calculator, and just going back to what we did in class, substitute it all in and comes out with 500, what is that, 519,63120. So that's if we want to find the constant term where the powers of x's cancel out. The next problem we looked at was finding a term, a particular term where we have two binomials, in this case a binomial and a trinomial multiplied. So this is just an easy example. You would have done something like this in year 10. So if I want to find a term in x squared, we can see that we could make x squared, because remember we've got to do, remember you do all this multiplying, you multiply everything by everything, and everything by everything. And if we want to think, well, where do I get an x squared made? That's going to happen when I go this one, when I going 2 times x squared, that's going to make an x squared term. And the other one is when I go minus x here times 3x. That will also make a term that involves x squared. So the term is going to be 2 times, it's a times x squared, whoops, squared. Then we've got, I'll add it because we've got to add those two terms, but it's minus x times 3x. So now we end up with 2x squared minus 3x squared equals minus x squared. So in other words, if you expanded all that expression and simplified, combined all like terms, the term that has x squared in it would be minus x squared. So that's nice and easy. We saw we multiplied that by this expanded form to find the correct terms. But what we've got is something obviously more complicated, where we still have our binomial, but we're multiplying by something that has a much bigger expansion. And there's no way we want to expand all of that out. We know that if we did it, we'd end up with that first part, that this will be 3 to the 9th, x to the 9th, and then you'll have some other term in x to the 8th, because you'll take 8 of these and 1 of those and the coefficient, and it keeps going all the way down until eventually you've got none of these and 9 ones plus 1 to the 9th. That would take quite a while to do. But if we want the term in x to the 6th, we then want to say, well, when I do this multiplying, I'm going to go 2 times. In here, there will be a term that's going to be x to the 6th, because they're going down in ones. It's going x to the 9th, x to the 8th, x to the 7th, etc. So we want to get 2 times that term, and then pick another colour. We want to go minus x times the term after that, which is going to be something or other. We don't know what the coefficient is, but it'll be something to the power of 5, x to the power of 5. So we want these two terms to multiply with this, so we end up with our powers of 6. Pardon me. So we always go about writing up our general term. So we want the term in x to the 6th equals. we want to go 2 times, now our term, 3 brackets, remember, each time. The coefficient, we've got n is 9, oops, so we want 9. Now in here we have 3x and 1. If we're wanting x to the 6, we want this is a power of 6, this is a power of 3, so this is a 3 down here. Then the next term we want to add on to that, so this was the one I did in red, where we're going x to the 6th and multiplying with the 2. Now we want to do the green one. We want to go minus x times our term, 3 brackets. This is 9, here's our 3x, this is our 1. This time we want a power of 5 on it. So we want where it gets the, whatever it makes the power of 5. So that means this is a 4 and this is a 4. Clear out that. Okay, so, this was our green one, just to colour code it for you. That's minus x times our term in x to the 5th. So now we just put these into, we want 2 times 9c3, we want 3 to the 6th, and we've got x to the 6th. 1 cubed is 1. Plus, but we've got a minus over here, so we're going to go minus x times, and we'll have to look up 9c4, times 3 to the 5th, and then we've got x to the 5th. 1 to the 4 is 1. So you can now put all that into your calculators. All right, and when you do that, just going back to our notes from today, we find out that 9c3 comes out as 84. 3 cubed, 3 to the 6 is 729, and there's our x to the 6. There's our minus x. 9c4 is 126. 3 to the 5th is 243, and we've got x to the 5th. These x's multiply, so we end up with our x to the 6. Subtract them, and there's our term in x to the 6th. So usually there'll be 2 places to make that term, and you just need to find those 2 places. The next one is where we, in this case, want to find a power of n. So what is the power on this expansion? When we know the third term is 36x squared. The third term along your Pascal's row means r is equal to 0, 1, 2. So r equals 2 in this case. All right, so if we know term 3 equals 36x squared, that's going to equal, let's do our 3 brackets. We don't know what n is. We have 1, oops, and we have an x. Let me just fix that up. Don't want a dash in there. 1, this is our x. If this is x squared, then this must be a 2 here. We know r is equal to 2. If that's 2, then this here must be n minus 2. So 36x squared equals NC2. 1 to any power is 1, so we're left with x squared. We now have a common factor on both sides, so we can cancel our x squareds out. So we now know that 36 is equal to NC2. So the question is, how do we solve that? Hopefully you might remember we have a formula for NCR, and that equals n factorial divided by r factorial times n minus r factorial. So we can use that rule with this calculation. So 36 equals n factorial over 2 factorial n minus 2 factorial. All right. And get rid of emails. Okay, so now we have to work out, well, how do we do this? So expand your factorial notation. So 36 equals n minus 1, n minus 2. Oh, look, we're starting to see something that's going to match. Dot, dot, dot. All divided by 2 times 1, then n minus 2, n minus 3, etc. So now we can see how we're going to get some things that cancel. So that will cancel, n minus 3, and everything else continuing will cancel out. So now we can say that 36 equals n minus 1 over 2. Multiply both sides by 2. So we're at the moment considering that we're in a non-calculator paper. There's ways of solving this, obviously, if you're in a calculator paper, but you need to be able to do this without a calculator. Minus 72, so you should be going, oh, it's a quadratic. Yes, I love quadratics. So, no calculator, but I know how to factorize. So this factorizes as n minus 9, n plus 8. So n is equal to 9 or minus 8. We can't have minus 8. That doesn't work for this problem because we're powers of binomials. We're not doing negative powers. So we've now found out that n equals 8. If you want the fourth term, then that means r equals 3. So then fourth term equals nc3, and we had 1 plus x, wasn't it? Just checking. Good. 1x, and it's 3 here. This is 6. So we therefore you need to put that in your calculator. nc3 x cubed, and when we check with the answer that we did in class, putting that in your calculator, I think n9c3 comes out here as 84 x cubed. So that takes you through those questions. The only other one remaining was to have a go at 9b. That's a more challenging one. We'll write that up and have that with the smartboard notes for you anyway. Thanks. All the best for now. Thanks for listening.